In this video, I'm going to explain about the various arithmetic operations carried out in a computer. We know that in a computer, central processing unit consists memory and processor. The processor consists of arithmetic logic unit, control unit and inbuilt registers. This arithmetic logic unit is responsible for performing arithmetic operations like addition, subtraction, multiplication, division, and logical operation, logical and or. Arithmetic operations to be performed is based on the data type. Based on the number system, two basic data types are implemented in the computer system. They are fixed point numbers and floating point numbers. In integer numbers, a radix point is fixed and assumed to be to the right of the rightmost digit. As a radix point is fixed, the number system is referred to as fixed point number system. The fixed point number system is used to represent positive or negative integer numbers. The floating point number system allows the representation of numbers having both integer part and fractional part. The fixed point numbers are represented in two forms. It may be a signed integer or unsigned integer. The unsigned numbers represent positive numbers. The signed numbers can be represented in three ways. The signed numbers can be represented as signed magnitudes, or it can be represented in ones complement method or twos complement method. In all three formats, the most significant bit is 0 for a positive number and the most significant bit is 1 for negative numbers. In signed magnitude system, negative value is obtained by changing the most significant bit from 0 to 1 of the corresponding positive value. For example, consider positive number 5. So 5 in binary form it is represented as 101. To represent it is a positive number, the most significant bit is represented as 0. To get a value for negative value 5, it is represented by, so 5 means 101. The most significant is changed from 0 to 1 to represent a negative number. In ones complement system, negative values are obtained by complementing each bit of the corresponding positive number. For example, to represent a negative 5, so the binary form of 5 is 0101. This is for positive value of 5. To represent in ones complement, these values are complemented. This is 1010. In two's complement system, the two's complement of a number is obtained by adding 1 to the ones complement of that number. For example, minus 5 is obtained by complementing each bit in 0101. Then 1 is added to that. So we are getting 1011. Addition and subtraction of sign magnitude data. We designate the magnitude of two numbers by A and B. When the sign numbers are added or subtracted, we find that there are 8 different conditions to consider depending on the sign of the numbers and the operation performed. These conditions are listed in table. In case if both the numbers are positive numbers, the two values will be added and the result value will be a positive one. In this case, if any one of the number is a negative one, then the smallest number will be subtracted from the largest number and sign of the largest number will be taken for the result. If both the numbers are negative, then the two values will be added and the result will take a negative number. When the signs of A and B are same, add the two magnitudes and attach the sign of the result is that of A. When the sign of A and B are not same, compare the magnitudes and subtract the smaller number from the larger number and give the sign of the larger magnitude to the result. So practically, in case of This is the circuit to implement the addition and subtraction. For example, you consider A plus B. So the value of A is loaded in a register called accumulator register, and the value of B is loaded in B registers. The two values will be added using parallel adder, then the result will be stored in accumulator A register. In case of A minus B, A value is loaded in A register, that is an accumulator register. B value is loaded in B register. This mode signal controls whether it is addition or subtraction operation. In this case of subtraction operation, the 2's complement of the B value is found using this complementer, and then it is added in the parallel adder with the A value. Then finally the result is stored again in the accumulator. Next one is the multiplication process. Multiplication process involves the generation of parallel partial products, one for each digit in the multiplier. These partial products are then summed to produce the final product. First one is called as a multiplicand, multiplier. These are called as a partial products. These partial products are added to get the final product. In the binary system, the partial products are easily defined. When the multiplier bit is 0, then the partial product is 0. When the multiplier is 1, the partial product is the multiplicand. The final product is produced by summing the partial products. Before summing operation, each successive partial product is shifted one position to the left relative to the preceding partial product. Here, each partial product is shifted to the left before adding. If the multiplier is 1, then the result will be same it as multiplicand. If the multiplier value is 0, then the multiplier result will be 0. This is the circuit used for the multiplication. So here initially the product is set to be 0. The multiplicand is loaded in the accumulator register, and a multiplier value is loaded in a shift register. We'll check the multiplier value. If it is 1, then the multiplicand is added in this arithmetic logic unit with the initial product value, that is it is added with 0, and the result is again stored in this product. Then multiplicand is shifted to the left position by 1 bit. At the same time, multiplier is shifted to the right position by 1 bit. Then the multiplier is checked. If this value is 1, again the result stored in the product is added with the multiplicand value, or if it is 0, no addition is performed. The next step, the multiplicand will be shifted to the left side by 1 bit, and multiplier will be shifted to the right bit by 1 position. This is the flow chart. So the multiplication functions. So initially the multiplier values checked. If it is 0, then shift the multiplicand register to the left by 1 bit, and shift the multiplier register to the right by 1 bit. If multiplier is 1, we have to add the multiplicand to product and place the result in the product register. So this, if it is a 32-bit numbers are multiplied, this condition is repeated for 32 times. If 32 times this process is repeated, it will complete the multiplication. Thank you.